Well, folks, this is neither an eye test nor is it a lesson in some obscure Central European language. That is not TVM Intro.AVI. This is, in fact, your introduction to time value of money. So let's take a look at what our letters are and what they mean and how we can help you figure out this somewhat complicated aspect of finance. So, time value of money. Hey, your book tells you what time value of money is. It says that, first of all, a dollar today is not the same as a dollar next year. Well, I think we all can appreciate that. After all, inflation gets in the way. But there's something else that gets in the way, too, in a business sense, and that's the risk element, all of which you'll learn about when you get into chapters 10, 11, and 12, when you start looking at the cost of capital. That's the measure of the risk, or the amount of return that a business person got to have. He's got to have it in order for his dollars today to be worth some investment return in the future. But let's take a look at this. Time value of money. And there are 5 elements that you'll need. Now, they're discussed in various ways in your chapter 9. But let's look at them because Secretary Donald Rumsfeld had something to say about this, and we'll get to that in a moment. Present value, interest rate, number of periods, annuity value or payment size, and future value. Those are the 5 components for the time value of money determination. And like anything in algebra, if you know all of them but one of them, you can find that one. It's pretty straightforward. So, let's look at some of the relationships. We'll get rid of our little acronyms here. And we'll start off with the simplest one. Let's say I put $1,000 in the bank today. That means that's the present value. $1,000. That is also what we call a lump sum. Put $1,000 today, and the question is, what is its future value in 5 years if my bank is paying me 6% interest per year? And we'll just consider the simple case of annual compounding here. So, what do we know? We know present value. We know the time period. We know the interest rate. And we also do know A, or the annuity size, the payment, because A in this case equals 0. There's no periodic payment into our account. Just that initial $1,000. So, how do we figure that out? Well, it's really pretty simple. And your book gives you the relationship that the future value is equal to the present value times the future value interest factor for the number of periods and the interest rate. So let's just draw a little box around that. And then we're going to take a look. Let me walk around behind the camera and see if I can hold up this thing. I've sent you by email something I call time value of money tables. And this is the Appendix A. Appendix A, which gives us the future value of, I hope you don't get too seasick watching this thing wiggle around, the future value of $1. So, here we'll see our equation that future value equals present value times 1 plus I to the n. Well, 1 plus I to the n is our equation for future value. That is the future value interest factor, 1 plus I to the n. So, now, what do we have? Well, we've got 5 periods. So I come down here to the row 5 there, and I've got 6% interest. I come across to the column that says 6, and I see a value of 1.338. I know that there's $1,000 times 1.338, so I will have $1,338 in the bank in 5 years if I just let it sit there. Now, isn't that simple? Step one, and this applies to any kind of mathematical dilemma, mathematical problem. And it applies to lots of things, and it's a process that I found very helpful, especially in some of the more complex things I've had to do. The first thing you want to do is you figure out, what do you know? Okay, that's pretty important, and you'll notice we did that. We said, well, we know what the present value is, we know the time, we know the interest rate, and then what do you not know? Another pretty important question. And, well, we decided we didn't know the future value. That's what we were trying to figure out. And then step three, this is sometimes a tricky one, is what tool helps solve the question? Okay. Well, in our time value of money, there are 4 fundamental tools, and we're just going to look at them very quickly. Oh, just as an aside, our good friend Donald Rumsfeld, when he was Secretary of Defense, he drew up this little chart, and he said, well, there's these things you know and things you don't know. Okay? And also, there's things you know and there's things you don't know. Well, what does that have to do with anything? Well, the things you know, that's easy. The things you don't know, well, that's pretty easy too, because we can apply some tricks then, and then we can get into that. The things you don't know that you know, well, that can create a problem. If you don't know you know it, then you're going to repeat the same mistakes over and over again. So the idea is to try to figure out what you know that you know. And here's the real dilemma. And I'll draw a box around that. The things you don't know that you don't know, well, that's called blissful ignorance in my book, and that's what this course is designed to help you eliminate, is if you at least know you don't know it, you got a chance to figure it out. That's a lot of what your graduate school is doing for you. So, let's look at our 4 basic relationships. Okay? We've got that the future value equals the present value times the future value interest factor for the number of periods and the interest rate. Okay? And our future value interest factor is 1 plus, that's times 1 plus I to the n power, where n is the number of periods and I is the interest per period. We also have that the present value is the future value times the present value interest factor for n periods and I interest, and that's equal to the future value times 1 over 1 plus I to the n. Well, you'll notice here that my future value interest factor equals 1 over the present value interest factor. That's a pretty nice thing to have in your hand, in your tool also. So there we go. Those are the items 1 and 2, and this is when you have a lump sum with no payments. Lump sum, no payments. Okay, so those are items 1 and 2 of our list. Now we'll get to the next one, and everybody always tries to figure out, well, what are my car payments going to be and all that. So we now have something called an annuity, which is a periodic payment of an equal amount. Periodic equal payment. That's the annuity. Okay, so we now have to bring that into the equation because the future value of an annuity is equal to the annuity payment, okay, times the future value interest factor for an annuity for N periods and I interest rate. Now that's where it gets a little bit more complex. And if you'll notice at the top of Appendix C, you've got a little equation there. Here we go, Appendix C. There's a little equation that gives us our same equation that I wrote on the chalkboard. Okay, there it is. And here it is back. You see that thing in the brackets? That is the future value interest factor. Now, you can go ahead and solve that out by sticking in I and N. I, of course, is always given in decimal form. So 6% interest would be 0.06. But you can do that, or down in the table, it's going to give you the computation for that particular I value. And I apologize for the lack of focus on this darn little camera of mine, but there you go. So I've got the number of periods on the end and the number of and the interest rate along the top. And you simply find the item that corresponds to the number of periods and the interest rate. This one being for Appendix C, future value of an annuity. Appendix D comes along and it gives you the present value of an annuity. So, what do you think so far? Let's write the other one down. The present value of an annuity is equal to the annuity payment times the present value interest factor of the annuity for N and I. And I think I've got just about 1 minute, so let's do a simple problem with an annuity, okay? A simple problem. Okay, and the question is, you're going to buy a new car for $20,000. Okay? That's your cost of the new car. Let's say you're paying 6% interest to the car dealer, and to simplify it again, folks, let's make it 5-year loan, but you're going to make annual payments. So N equals 5, okay? And the payments are, I have no idea. I just don't know. But what we do know is that for either one of these equations, the future value of the annuity is equal to the payment times the future value interest factor of the annuity, or the present value of the annuity equals the payment times the present value interest factor of the annuity. Well, let's pick this one because we know that the present value of these payments is $20,000. The bank's giving you $20,000 today. You got it. That's the present value. Yet over the period of payments, you have to, in fact, make the right number of payments to pay it off, and it's going to be a little bit more. So let's use this equation. Okay? So my $20,000 is equal to the annuity times the present value interest factor for the annuity for 5 and 6%. And let's come back around here. So present value of annuity, let's pick up table 6. Okay? And we're going to look here at 5 periods, 6%, and you see that the value there is 4.212 off of Appendix D, 4.212. So this is equal to A times 4.212 equals $20,000, or A equals 20,000 divided by 4.212. And that'll give you the payments. So let's calculate it real quick. I hope I don't run over. My darned YouTube only gives me 15 minutes of time. So 20,000 divided by 4.212 equals $4,748 that I'm going to pay every year. Multiply that times 5. The difference between the 20,000 will be the amount of interest you pay. If you have any questions, be sure you ask me. Have a great day.